to Study Room. Before starting the lecture, I would like to say, don't let the numbers bother you, because mathematics is all about playing with numbers. So in today's lecture, we'll be dealing with a brand new chapter of mathematics, that is direct and inverse proportion. So let's get started. Before directly jumping into the main concept of direct and inverse proportion, let me discuss with you a few examples, and these are somewhat real-life examples. So the first example that we have over here is, if the number of articles purchased increases, the total cost also increases. Let's say I am buying 1 kg of sugar and it costs me rupees 30. If I increase the quantity of sugar that I want to 2 kg, then my cost will also increase. The second example we have over here is that more the money deposited in the bank, more is the interest earned. If I am depositing 1000 rupees, let's say I am earning an interest of 100 rupees from that. And if I increase the amount I am depositing, then the amount that I'll be earning as interest will also increase. The third example we have over here is that if I increase my speed, then the time taken to travel the same distance decreases. Let's say I have to travel from my house to the railway station. The distance is constant. Now to travel the same distance, if I increase my speed, then the time taken to travel the same distance will decrease. So, the motive of discussing these examples are that in each of these examples, we have two main quantities, or basically we can call it variables. So, we have two main variables in each of these examples and they are somewhere related to each other. Either increase in one quantity is causing increase in the other quantity, as we discussed in example number 1 and 2, or increase in one quantity is causing decrease in the other quantity, as we discussed in example number 3. So, now let us move into the main concept of direct and inverse proportion. Now, what is direct proportion? To understand this concept, let us consider two variables x and y. Now, if the value of the variable x always increases or decreases with the respective increase and decrease with the value of the variable y, then x and y are said to be in direct proportion. In simpler words, if x is increasing, then y is also increasing in the same proportion. And if x is decreasing, y is also decreasing in the same proportion. As we discussed in example number 1, if we increase our quantity, then the amount that we have to pay, that is the cost, will also increase. Or we discussed in the second expression. That was, if we are increasing the amount of money that we are depositing, then the interest that we will be earning will also increase. So these two examples are basically examples of direct proportion. Here the variables x and y are directly proportionate to each other. Let's discuss an example now. So, we have a table in this example which represents the weight of the sugar in kg and its corresponding cost in rupees. So, if we are having 1 kg of sugar, it costs rupees 36. When the weight of the sugar is increased to 3 kg, it is costing us 108, and similarly, when the weight of the sugar is 5 kgs, it is costing us 180 rupees. So, what is happening is, in the first place, the weight of the sugar is getting multiplied 3 times. From 1 kg, it is becoming 3 kgs. So, the cost will also become 3 times. 1 to 3, the weight is changing. The cost is changing from 36 to 108. 36 multiplied with 3 gives us 108. In the second case, the weight of the sugar is becoming 5 kg. That means it is getting multiplied 5 times. 1 multiplied with 5 gives us 5. So the cost will also become 5 times. From 36, it will become to 180. Why? Because 36 multiplied with 5 gives us 180. So from this example, we can observe that this is an example of direct proportion. Why? Because as the weight of the sugar is increasing, its cost is also increasing in the same proportion. Weight is getting multiplied 3 times, the cost is also getting multiplied 3 times. Weight is getting multiplied 5 times, the cost is also getting multiplied 5 times. So, in a similar way, we will be calculating the cost of the sugar when its weight is 6 kgs, 8 kgs and 10 kgs. Now, when the weight of the sugar is 6 kg, that means it is becoming 6 times. It is getting multiplied with 6. So, the cost will also get multiplied with 6. So, 36 multiplied with 6. It will be 36 multiplied with 6, which ultimately gives us 216. Now, Again, similar way, when the weight is becoming 8 kg, that is, it is getting multiplied 8 times. So the cost will also get multiplied 8 times, that is 36 multiplied with 8, and it gives us 288. In the similar way, when the weight of the sugar is 10 kg, its cost will become 10 kg. So we'll have 36 multiplied with 10, that gives us 360. So this is an example of direct proportion where the weight of the sugar is increasing and henceforth the cost is also increasing. So increase in the weight of the sugar is causing a corresponding and respective increase in the cost as well. Now let us consider another example. Suppose we have a car that uses 4 liters of petrol to travel a distance of 60 kilometers. Now just consider in general. If I am increasing the quantity of petrol that I have, then the distance that I can travel will also increase. More the quantity of petrol, more will be the distance traveled. So we can say that the quantity of petrol and distance traveled, they both are directly proportional to each other. That means they are in direct proportion. So now over here, we had 4 liters of petrol initially and that was sufficient to travel 60 kilometers. Now the quantity of petrol is increasing from 4 to 8. That is, it is getting multiplied 2 times. So these two quantities are in direct proportion. The distance will also increase and it will also become twice. That means 60 will be multiplied by 2 and the distance that can be traveled in 8 liters of petrol will be 120 kilometers. Again, from 4 liters of petrol, it is increasing to 12. That is, it is getting multiplied 3 times. So the distance will also get multiplied 3 times. So we will have 180 kilometer that can be traveled with 12 liters of petrol. Now again, the quantity of petrol is increasing to 16 liters. That means it is getting multiplied 4 times. So in this case, the distance will also get multiplied 4 times. So we'll have 60 multiplied with 4, that gives us 240 kilometers. Now from 4, the quantity of petrol is increasing to 20 liters. That means it is getting multiplied 5 times. So again, the distance will also get multiplied 5 times. So 60 multiplied with 5 gives us 300 kilometers. Now the petrol is increasing to 24 liters. That means it is getting multiplied 6 times. So the distance will also get multiplied 6 times. That means 60 multiplied with 6, which gives us 360 kilometers. So in this way, we have to solve such problems. The first thing is that to figure out the relationship between the two quantities. Here, the increase in one quantity was causing an increase in the other quantity. So this was in direct proportion and henceforth we solved the problem in this method. Now that we have solved this problem, let us try making an observation. Let us consider the petrol in liters as a variable x because it is keeping on changing, it's changing with time. And let us take this distance in kilometer as y. Again, an other variable because the distance traveled is also changing. It is not constant. Now, let us try doing one thing. That is taking out the ratio of these two variables. That is x by y. Now, in the first case, when x is equal to 4 and y is equal to 60, the ratio will be 4 divided by 60 and this gives us 1 upon 15. Similarly, when we try to take out the ratio in the second case, that is 8 divided by 120, again we'll be getting 1 by 15. And then in the third case, when 12 is divided by 180, the ratio is 1 by 15. And in each of the following cases, we will get the ratio as 150. So from here we can conclude that if x and y are in direct proportion, then this ratio, that is x by y, is a constant. That means it remains same throughout. In each and every value, we will get a constant when we take out the ratio. So from here, we can take this y on the right hand side. So over here it is getting divided. When it will go to the right hand side, it will get multiplied with k. So we can also say that a variable x is actually k times the variable y. K can be any constant, 1, 2, 3, 4, 5. So over here we can see that 60 is nothing but k times 4, and similarly 120 is nothing but k times 8. This k is constant. 60 is 15 times 4. 120 is 15 times 4. So this k remains constant in each and every case. So this was our conclusion in case of direct proportion. So in general terminology, we can write it as x1 upon y1 is equal to x2 upon y2 and so on, like will be equal to x3 upon y3 will be equal to x4 upon y4, where y1 and y2 are the values of y corresponding to x1 and x2. So this was the conclusion drawn in case of direct proportion. So very important conclusion that we drew from the previous example was that if we have two variables x and y and they are in direct proportion with each other, then their ratio will be a constant number, or the first variable can be represented as k times the second variable. X can be written as k times y, and this k is a constant number which will be the same in each and every case. So this was a very important and necessary condition for two variables to be in direct proportion. Now let us try solving another example. We have a minute hand of the clock and we have fixed it at 12. Now we have to record the angle that the minute hand of the clock is making with respect to this initial position as the time passes. So here the time passed is taken in minutes, this t is taken in minutes, and the angle turned is taken in degrees. Now what happens is that when the time passed is 15 minutes, the angle moved is 90 degrees. It's but obvious. Here we have the minute hand of the clock. It is fixed at 12. Now within 15 minutes, it will move till here and the angle made is 90 degrees with respect to the original position. So this was the first observation that we recorded. So first of all, we have to think that whether it's a direct proportion or not. With increase in time, the angle turned is also increasing. Initially, the angle turned was 0. As the time increased to 15, the angle turned also increased to 90 degrees. So this is a case of direct proportion. Now, let us consider this angle turned as the variable x and time passed as the variable y. So if I take out the ratio of x by y, that is x by y, it will be equal to the value of x is 90 and y is 15 in the first observation. So I'll write 90 divided by 15. This gives us 15 gets cancelled up and it leaves behind 6. So we have that x is equal to y times 6 times y. Now I taught you one thing, that in case of direct proportion we have x is equal to k times y, where k is a constant. So from here we can say that this 6 is the constant in this question. Now we will try calculating the other values of the angle turned in the given time. The time too that has been given to us is 30. So this is a direct proportion. So in 30 minutes, the angle moved will be 30 multiplied with 6. Why? Because we have calculated this expression. X is equal to 6 times y. So here the value of xa2 will be equal to 6 times the value of y, that is 30. 6 multiplied with 30 gives us 180. So the minute hand, when it moves 30 minutes, the angle is a straight angle, 180 degree. Next up, we have the time passed in minute as 45 minutes. So we again know that x is equal to 6 times y. So a3, which is x, will be equal to 6 times of 45. It will be 6 times of 45 because 6 is the common constant. So 6 times of 45 gives us 270 degrees. So in 45 minutes, the minute hand will be moving from here till here. So this angle is 270 degrees. Next up, we have the time as 60 minutes. That means 60 minutes has passed and now we have to calculate the angle that is turned by the minute hand. So in order to do so, again this value of x will be equal to 6 times y. That is 6 times the value of y, which is 60. So our answer will be 360 degrees. Yes, it's obvious, like when we are over here and the minute hand is covering entire 60 minutes, that is 1 hour, then the angle turned will be a complete angle, that is 360 degrees. So this was an example of direct proportion. Now another thing we have to do is to calculate this ratio of t by a. T is the time passed and a is the angle turned. So we have to calculate it. So let us consider the first case where we have t1, a1. So we'll write t1 upon a1. That is nothing but equal to 15 upon 90. So this gives us 1 upon 6 because 15 6 times 90. Let us check what is the next case. Here we have T2 upon A2, that is 30 upon 180. This gives us again 1 by 6 because 0, 0 gets cancelled up and 3 gets cancelled up with 18, leaving behind 6. So we have 1 by 6. Again we have to calculate T3 by A3, which is 45 divided by 270. 45 6 times 270. So again we have 1 by 6. And lastly we have 60 divided by 360. The 0, 0 gets cancelled up and we have 6 divided by 36, that is 1 by 6. So we can observe over here that when we are taking the ratio of the two variables t and a given to us, then in each of the cases the answer is same. So this is a case of direct proportion. Let's try solving another problem. So here we have to fill the following table with the ratio of age of the child to the corresponding age of the mother. So here the age of the child is represented with C and age of mother is represented with M. And it has been given that the age of the child 5 years ago was 10 and the age of mother 5 years ago was 35. So what will be their present ages? The present age of the child will be 10 plus 5. So it will be 10 plus 5 equals 15. Because within 5 years will be added up to 10 years. So it will sum up to 15 years. Now, mother was 35 years of age 5 years ago. So now she'll be 35 plus of 5, which is equal to 40. Now, what about 5 years hence? Like, what about their age 5 years after from this day? 5 years after or 5 years later, their age will be 15 plus 5, which is equal to 20. Now, talking about the mother's age, 5 years later, mother's age will be 40 plus 5, which is equal to 45. Now what we have to do is we have to calculate the ratio of the age of child with the corresponding age of the mother and see whether it is in direct proportion or not. So in the first case, C is 10 and M is 35. So we have 10 by 35. So 5 2 times and 5 7 times. So we have equals 2 by 7. Now, in the next example, we have the age of the child as 15 and mother as 40. So, the ratio of C by M will be 15 divided by 40, 5 3 times 15 and 5 8 times 40. Next up, we have the age of child as 20 and mother's age as 45. Now, when we cancel it up with 5, we get 5 4 times 20 and 5 9 times 45. So in this example, we are observing that the ratio of the age of mother and child is not a constant. In the first case, we have 2 by 7. In the second case, we have 3 by 8. And in the third case, we have 4 by 9. So this question is not an example of direct proportion. That means that the age of child is not in direct proportion with the age of mother. Now let us draw some conclusion from the previous two examples that we saw. In the first example, we had two variables. One was the angle that was covered by the minute hand and the second was the time. Both of them were increasing and they were increasing in a direct proportion. That means the ratio of the two variables was constant. So in that case, the variables were in direct proportion. But in the second example that we solved, we again had two variables. One was the age of mother, another the age of son. In this case, the ratio of these two variables was not constant. So over here we can see that it was not in direct proportion. Though both of the variables were increasing, age of child was also increasing, age of mother was also increasing, but they were not in direct proportion. So from here we can draw a conclusion that if we have two variables and both of the variables are either increasing together or decreasing together, then it is not necessary that they will always be in direct proportion. They may be in direct proportion or they may not be in direct proportion. For example, physical change in human beings occur with time, but not necessarily in a predetermined ratio. This means that let us consider height or weight of individual. As we grow up with time, our height and weight increases. So time is also increasing, our age is increasing and height and weight is also increasing. But this increase is not in a predetermined ratio. So here we can say that it is not in direct proportion. So the necessary condition for direct proportion is not that they will increase or decrease together. The necessary condition is that the variables have to increase or decrease in the same and fixed proportion. Or we can say that the ratio should be fixed. Now we have another example with us. Over here, there is a table given to us with two variables. One is x and y, and we have corresponding values of x and y. Like we have 20 over here. So the corresponding value for 20 in terms of y is 40. Now we have to check that whether these two variables are in direct proportion or not. So for that, I told you that the necessary condition is the ratio of the variable needs to be a constant. So let us find the ratio, that is x by y. In the first case, x by y is 20 divided by 40, which gives us 1 by 2. In the second case, we have 17 and 34. So we have 17 divided by 34, which is again 1 by 2. In the third case, we have 14 and 28. So 14 divided by 28. So we have 14, 2 is 28. So it's again 1 by 2. Next up, we have 11 and 22. 11 divided by 22 gives us 1 by 2. Next we have 8 by 16. So 8 by 16 gives us 1 by 2. Next we have 5 by 10, which again gives us 1 by 2. And lastly we have 2 and 4. So 2 divided by 4, which is again 1 by 2. So here we can observe that the ratio of the two variables x and y is a constant, that is 1 by 2. So this is a constant 1 by 2. So we can say that yes, x and y are in direct proportion. Let us try solving another similar type of problem and check whether the variables x and y are in direct proportion or not. So the table given below is x and y, and we have first up is 6 and 4. So let's try finding out the ratio x by y. In the first case, x by y will be 6 by 4, which is equal to 3 by 2. In the second case, we have 10 and 8. So we have 10 by 8, which is equal to 5 by 4. Next up, we have 14 by 12, which is equal to 7 by 6. Next, we have 18 by 16, because the value of x is 18 and y is 16. So we have 9 by 8. Next up, we have 22 by 20, which is equal to 11 by 10. Next up, we have 26 as the value of x divided by the value of y is 24. So from here, we get 13 by 12. And lastly, we have 30 by 28, which is equal to 15 by 14. So from here, we can conclude that the ratio in each of the case is not same. So they will not be in direct proportion, because for two variables to be in direct proportion, this x by y ratio needs to be a constant number. But here x by y is not a constant number k. So the answer to the question will be that no, they are not in direct proportion. Let's try solving another problem of the same type. Again, we have two variables x and y, and we have been given the corresponding values of y and x, and we have to see whether x and y are in direct proportion or not. So for that, we have to first calculate the ratio of x and y and check if it's a constant, then it will be in direct proportion. If it is not, then it won't be in direct proportion. So first we have 5 as the value of x and 15 as the value of y. So this gives us 1 by 3, because 3 times 15. Next up, we have 8 by 24. This gives us 1 by 3. Next up, we have 12 by 36. This again gives us 1 by 3. It's looking like it will be in direct proportion. Let's move forward and check. Next up, we have 15 by 60. But over here, 15 by 60 will give us 1 by 4. So the proportion is getting changed. Next up, we have 18 by 72. This again gives us 1 by 4, because 18 multiplied with 4 gives us 72. Next up, we have 20 divided by 100. This gives us 1 by 5. So here we can observe that x by y, this ratio is not a constant k. So x and y will not be in direct proportion. It will not be in direct proportion because for two variables to be in direct proportion, their ratio needs to be a constant number, and over here ratio is changing with each value. For the first three value, the ratio is constant, but then it changes to 1 by 4 and then it remains constant till the next value, then again it changes to 1 by 5. So it will not be in direct proportion. Now let's try a different and a new problem. So what we have over here is time period as a variable, let's say x. So time period is a variable, it's keep on changing. 1 year, then the time period becomes 2 year, and then it becomes 3 year. What we have to do is, we have to at first calculate simple interest when the principal given is 1000 rupees and the rate is 8% per annum for first year, second year and third year. That means we have to calculate simple interest for these three cases. And then we have to also calculate compound interest with principal equals rupees 1000 and rate equals 8% per annum for each of these three cases where the time period is changing from 1 year to 2 year and from 2 years to 3 year. And then we have to see that which of these, that means whether simple interest or compound interest is in proportion, in direct proportion with the time period. So basically we have to check the ratio of simple interest and time period and compound interest and time period and see that whose ratio gives us a constant, that particular thing will be in direct proportion with the time period. So first of all, let's calculate simple interest. For doing this, we have to use the formula of simple interest. So we know that formula for calculating simple interest is P, that is principal, multiplied by R, that is the rate of interest, multiplied with T, whole divided by 1000. So this is the formula for simple interest, P into R into T divided by 100. I'm sorry, it was 100. Now, in the first case, we have to calculate simple here where time period T is 1, principal P is 1000, rate R is 8% per annum. So it will be principal equals 1000 multiplied with rate is 8, time given is 1 and it will be divided with 100 using the formula. So this 100 gets cancelled up and here we will cancel up 2 zeros. So we are left with rupees 80. So rupees 80 is the simple interest for the first year. Let's calculate the simple interest for the second year. Here again the principal will be same, it will be 1000 and then the rate is also same, that is 8. So principal and rate is fixed, only the time period is changing. Time period becomes 2 and then whole divided by 100. So this 100 gets cancelled up with 2 zeros and we are left with 8 multiplied with 2, 16. 16 multiplied with 10 gives us 160 rupees. Now we have to calculate simple interest for the third year as well. For doing so, what we have to do is, we have to take principal, that is 1000, multiplied with the rate of interest, that is 8, multiplied with the time period, that is 3, divided by 100. Now again this 100 will get cancelled out with the 2 zeros and we are left with rupees. Now 8 multiplied with 3 is 24, multiplied with 10 gives us 240. So we are done calculating simple interest. Now let's calculate compound interest for each of the 3 years. So for that we need to know the formula of compound interest. So the simple formula for compound interest is P 1 plus R by 100 whole to the power of T minus P again. So this is the formula for calculating the compound interest. We have to use this formula and calculate compound interest for 1 year, 2 year and 3 year, and the value of P and R will remain constant in all the three cases. So in the first case, principal will be 1000 and then we have 1 plus the rate of interest is 8, which is again a constant in all the three cases, 8 by 100. The time period in this case is 1 minus again principal, which is equal to 1000. So now we have to calculate it. Now just observe over here. Over here within the bracket we have 1 plus 8 by 100. So when we take 100 as the LCM, we get 108, that is 100 plus 8 divided by 100. So we will be left with 1000 multiplied with 108 divided by 100 minus of 1000. So this 2 zeros of 100 will get cancelled out with the 2 zeros of 1000 and we will be left with 1080 minus of 1000. So basically we have 1080 minus 1000. Now subtracting this, we get the compound interest as rupees 80. So rupees 80 is the compound interest in the first case. It is same as simple interest. Now let's see what happens in the case of 2 years. So in that case, again we'll take the same formula. First is the compound interest will be equal to P multiplied with 1 plus R by 100 whole to the power T minus P. So P over here is 1000 multiplied with 1 plus the value of R again is 8 divided by 100. But here the value of T will be 2 because we have 2 years minus of 1000. So let's calculate it. Again, this bracket thing, when we calculate it, 1 plus 8 by 100, we'll take 100 as the LCM and 100 plus 8 gives us 108 by 100. But this time we have the square of 108 by 100. So we will have 1000 multiplied with 108 square divided by, again 100 square gives us 10000, that is 10,000 minus of 1000. So over here we have like this 3 zeros of 10,000 will get cancelled out with these 3 zeros of 1000. So we have in the numerator 108 multiplied with 108 and this gives us 11664 divided by 10 we have and then we have subtracted by 1000. Now when we divide 1166.4 by 10, we get 1166.4 minus 1000. So subtracting these two, that is 1166.4 minus 1000, we will be left with rupees 166.4. So this is the compound interest for the second year. So it will be rupees 166.4. Let's calculate the compound interest for the third year. So in case of the third year, only T will change. All the other values will remain same. So the compound interest will be 1000 multiplied with 1 plus 8 by 100 whole cube minus this 3 I have taken because the value of T will be 3 in the third case. Minus of again principal which is again equal to 1000. So from over here we have 1000. Again this part within the bracket will give us 108 divided by 100. And we have to take the cube of 108 divided by 100. So taking the cube of numerator and denominator both. That will be 108 whole cube. And then we will also have 100 whole cube. So 100 whole cube will give us 100,000. This will be 100 whole cube. Minus of 1000. 108 whole cube gives us 1259712. Divided by we have 1000 subtracted with 1000. So we can write 1259712 divided by 1000 as 1259.712 minus 1000. So this ultimately gives us rupees 259.712. So the compound interest for 3 years will be rupees 259.712. Now what we have to check is that which type of interest is in direct proportion with the time period. So we have taken the time period as X and let's take the first case. Let us take simple interest first. Try finding out the ratio with the time period and then we'll take up the compound interest. So let us consider Y as the simple interest in the first case. Now let us find out the ratio of X and Y. We can take X by Y or we can either take Y by X as well based upon our convenience. Over here I am taking Y by X. So in case of simple interest, when I take Y by X, that is equal to, now in the first case Y is 80 and the corresponding value of X is 1. So it will be 80 by 1 which is 80. Now I have the second case, that is 160, the value of y, and the value of x is 2. So 160 divided by 2 gives us 80. So the second case also we get 80. In the third case, when you find out the ratio, 240 divided by 3, this again gives us 80. So we can say that this value, that is the ratio of these two variables, simple interest and time period, is a constant. So simple interest and time period, they both are in direct proportion with each other. Now let's try finding out the case in compound interest. Now in compound interest, when I similarly find out the ratio of y by x, so in this case what we get is y by x in the first case will be 80 by 1. In the second case, y by x will be 166.4 divided by 2. And in the third case, it will be equal to 259.712 divided by 3. Now, we find that this ratio, they are not same. 80 by 1 is not equal to 166.4 by 2, and this is not equal to this. So ultimately, we can say that this ratio is not a constant. So compound interest is not in direct proportion with time period. So our answer will be that simple interest is the interest which is in direct proportion with the time period. Now let's discuss something important. Basically, we have two types of interest. One is simple interest, other is compound interest. Now, in the previous question, we discussed the relationship of simple interest and compound interest with time. So simple interest was directly proportional with time, but compound interest was not directly proportional with time. Over here in this problem, what we will do is, we will observe the change in the simple interest and compound interest with respect to the principal. And we have to see that whether there is a direct relationship between principal and simple interest and principal and compound interest or not. That means in simple word, we have to just check that is simple interest and compound interest directly proportional with principal or not. So first we'll be talking about simple interest and then we'll be talking about compound interest. So in case of simple interest, if I have to check its proportionality, that means whether it is directly proportional with principal, what we have to do? We have to take out the ratio. As I taught you, if x is proportional with y, then the ratio x by y needs to be a constant. Similarly, if simple interest is proportional with directly proportionate with principal, then its ratio with principal should be a constant number. Let's check it. The formula for simple interest is P into R into T divided by 100, and then simple interest has to be divided by principal. So I'll write divided by principal. So this gives us P into R into T divided by 100 multiplied by 1 by P. So P and P gets cancelled off and we are left with R multiplied with T divided by 100. Now, in this question, it has been mentioned that the time period and rate of interest remains fixed. So when time period and rate of interest is constant, then we can say that this entire thing is a constant, because constant multiplied with a constant is a constant and then 100 again is a constant. So this entire thing is a constant. So we can see that the ratio of simple interest with principal is a constant quantity. It is a constant. So from here we can conclude that there is a direct proportionate relationship between simple interest and principal. Now let us find the case of compound interest. Is it directly proportional or not? So in case of compound interest, we have compound interest by principal, because we have to check that whether it is in proportionate with principal or not. So we have to calculate the ratio and check whether the ratio is a constant or not. So for doing so, I have to write the formula of compound interest. Now the formula for compound interest is P. Let's give a third bracket multiplied by 1 plus R is the rate of interest divided by 100 whole power of T minus 1, and then we'll close the curly bracket divided by P. Now this P will get cancelled up with this P and we will be left with 1 plus R by 100 whole power T minus 1. This is the required ratio of compound interest with principal. Now just observe, when R and T, both of them are fixed, that means they are constant. then this entire quantity that we got and in the form of ratio will also be a constant. So we can say that compound interest bears a constant ratio when it is divided with when it is divided with principal. So compound interest is also direct proportionate relationship with principal. So both simple interest and compound interest is in direct proportion with the principal when the rate and time, both of them are fixed. Now let us try solving another problem. Over here, the cost of 5 meter of a particular quality of cloth is given as rupees 210, and we have to find out the cost of 2 meters, 4 meter, 10 meter and 13 meter of cloth which is of the same type. Now, the first thing that has been given to us is the quantity of cloth. So this can be taken as the first parameter or the first variable. So I wrote quantity of cloth which is represented in meters in the first block, and then what we have to do is to write the second variable, that is its cost. So cost in rupees is the second variable given to us. Now the quantity of the cloth is 5 meter and the cost given is 210. So this is the first observation that has been given to us. Now let me tell you one thing. Quantity and cost will be in direct proportionate relationship. Why? This will be in direct proportion because when we increase the quantity, its cost also increases in the same proportion. That means the ratio of the two variable is fixed. So let's try finding out the ratio of these two variables. So here we have quantity and cost. Let's take cost as x and quantity as y and try finding out the ratio of x and y. So the ratio of x and y will be x by y, which will be equal to 210 divided by 5. And this gives us equal to 42. So from here we can conclude that x is equal to 42 times of y. This is a relationship between x and y. That is, I taught you earlier that x is k times y, then it is in direct proportionate relationship. So here this k constant is 42. Now we have to find out the cost when the quantity of cloth is 2 meters, 4 meter, 10 meter and 13 meter. So basically what we have to do is, we have to calculate the value of x for each of these corresponding values of y. And for doing so, we have to simply multiply each of the value with 42 because the value of x is 42 multiplied by the corresponding value of y. So we have to find the value of x over here. So it will be 42 multiplied with the corresponding value of y, that is 2, which is equal to 84. Similarly, we will solve this. The cost of 4 meter cloth can be solved in a similar way. What we have to do is, we have to multiply this constant 42 with the corresponding value of y, that is 4. And this gives us 168 rupees. Similarly, we have to multiply 42 with 10 because we have to find out the cost of 10 meter cloth. So this gives us 420. And in the last case, we have to multiply 42 with 13. So 42 will be multiplied with 13 and this gives us 546 rupees. So this will be the answer of the cost of 2, 4, 10 and 13 meter cloth. The only important thing to remember is to calculate the ratio of the two variable and then multiply this constant because the ratio in a direct proportionate relationship comes as a constant. So this constant needs to be multiplied with each and every value of variable y in order to get the corresponding value of variable x, which is cost. The next problem that we have over here is an electric pole 14 meters high casts a shadow of 10 meters. Find the height of the tree that casts a shadow of 15 meters under similar condition. So in this question, again we have two variables. One is the height of the object. In the first case, the object is an electric pole and in the second case, the object is tree. So the first variable, let us take it as x. So it is height of the object in meters. The next variable is the length of the shadow. I am considering it as a variable y. So what we have to do in solving these questions, we have to first construct this box and then take the variable x and y and write the value that has been given to us. So in the first case, the height of the object, that is the electric pole, is given as 14 meter. So in the first case, the value of this variable x is 14 and it casts a shadow of 10 meter. So the value of the variable y is 10 meter. Now, In the second case, we have another object whose height is unknown. The object is the tree. So what we have to do, we have to consider that let the height of the tree be x. Let the height of the tree be x meters. Now when I'm considering the height of the tree as x meters, so in this block I'll be writing x because x is the height of the second object. Now it will be casting a shadow of 15 meter. So the value of this variable y, that is the length of the shadow in meters, is 15 meter. Now this word similar condition actually means that these two quantities are in direct proportion. That means x and y, they are in direct proportion. Now what happens in case of direct proportion? We have a constant ratio. That means this ratio of x by y is a constant. So in this case also we can say that the ratio will be constant. If this is x1, this is y1, then x1 by y1 will be equal to x2 by y2. So let's do this. So over here we will have this ratio, that is 14 by 10 will be equal to x by 15. Because in a direct proportion, x1 by y1 is equal to x2 by y2. The ratio is always constant. So from here we can find out the value of x. X will be like, we will take this 15 on this side and it will go in the numerator side. So it will be 14 multiplied with 15 divided by 10. So 5 2 times 10 and 5 3 times 15. 2 multiplied with 7 gives us 14. So ultimately the height of the tree, that is x, is equal to 7 into 3, which gives us 21 meters. So 21 meter is the height of the tree which is capable of casting a shadow of 15 meter under the similar condition. So this is the method of solving these types of problems. The next problem given to us is, if the weight of 12 sheets of thick paper is 40 gram, how many sheets of the same paper would weigh 1 by 2 kilograms? Now, what we have to do over here is we have to find the number of sheets of paper that will weigh 1 by 2 kilograms. So for doing this, what we have to do? We have to take, let the number of sheets be x first. So let the number of sheets required be x. Now, we can see that the number of sheet and the weight is in direct proportion. Why? If we increase the number of sheet, then its weight will also increase. So first of all, we have to make this table and write the first variable, that is the number of sheet, and the second variable, that is weight of the sheet, but we'll be taking the weight in grams. So first information was that 12 sheets weigh 40 grams. So number of sheet was 12 and its weight was 40 grams. Now we have to calculate again the number of sheets. So we considered the number of sheets to be x. The number of sheets x and its weight is given to us as 1 by 2 kilograms. Now 1 by 2 is given in kilograms. So the first thing we have to do is to convert this in grams. In order to do so, what we'll do? 1 by 2. Now this 1 by 2 can also be written as 5 by 2. 5 by 2 kgs. In order to convert kg to gram, we will multiply it with 1000. So it is 5 by 2 multiplied with 1000. 2 gets cancelled up and we are left with 500. So 5 multiplied with 500 gives us 2500 grams. So this is the weight of x sheets of paper. We will be calculating x. So 2500. Now just because the number of sheets of paper and the weight of the sheet, both of them are in direct proportionate relationship. So we know that in this case what happens? We have a constant ratio. That means x by y is a constant. So in this case also we will write x1 by y1 will be equal to x2 by y2. Why? Because these two quantities are in direct proportion. So we will have 12 by 40, which is the ratio of the first information, will be equal to x by 2500. So from here we can calculate the value of x as 12 multiplied with 2500 divided by 40. I took 2500 towards the left hand side and that's why it went to the numerator part. Now this 0 gets cancelled up over here and 4 3 times gives us 12. So we have 3 multiplied with 250, that gives us 750. So the number of sheets required is 750. The next question we have with us is, a train is moving at a uniform speed of 75 km per hour. So this speed 75 km per hour gives us two quantities. One is the distance and another is the time. So the distance over here is in kilometer. So I'll be writing the distance as 75 km, and 75 km can be travelled in 1 hour. Now we know that 1 hour is equal to 60 minutes. Let's convert this hour in minutes. So we can see that 75 km distance is travelled in 60 minutes. So what I did is, I made this rectangular box and then wrote distance in kilometer and time in minutes. Because these are the two variables that has been given to us, let us name it as x and y. Now, the question asked over here is that, how far will it travel in 20 minutes? So we have to basically calculate the distance travelled in 20 minutes. Now, distance and time, they are in direct proportion, because as distance increase, time will also increase in the same proportion, given that the speed remains constant. So over here, what we have to calculate is the distance which is travelled in 20 minutes. Let us consider the distance travelled in 20 minutes as x. X is the distance travelled in 20 minutes and the time over here is 20. Now just because these quantities are in direct proportion, so we will have x1 by y1 will be equal to x2 by y2. Because we know that in case of direct proportion, the ratio of the two variables given to us is a constant. So over here, the value of x1 is 75, y1 is 60. So we have 75 by 60 will be equal to x by 20. So from here we can calculate the value of x as x is equal to 75 multiplied with 20 divided with 60. So 20 gets cancelled out with 60, leaving behind 3, and this 3 will get cancelled up and we will be left with 325 times. So the value of x is 25 kilometers. So from here we can say that 25 kilometer is the distance that is travelled in 20 minutes. Now the second part of the question is that what is the time required to cover a distance of 250 kilometer? Here the distance has been given, but we have to calculate the time. So the distance is 250 kilometers and we have to calculate the time that is required to cover this distance. Let us consider this time as y. Again, just because distance and time are in direct proportion, the ratio will be a constant. So let us compare with this ratio and this one. So we'll have 75 by 60, that is x1 y1 will be equal to x2 y2 will be equal to x3 y3. Let us consider this as x3 and this as y3. So 75 by 60 will be equal to 250 upon y. So from here we get the value of y as 250 multiplied with 60 divided by 75. Now 25 10 times is 250 and 25 3 times is 75. 3 1 times and 3 20 times gives us 60. So from here we have the value of y as 200 and y is actually the time in minutes. So we can say that y is equal to 200 minutes. So basically 250 kilometer distance can be covered in 200 minutes. So this will be our final answer. The next problem that we have with us is the scale of the map is given as 1:3 crore. So let's simplify this. This 3 crore can be written as 3 multiplied with 10 to the power of 7. Now, what does this 1:3 crore means? First, we have to understand the meaning of this sentence. This means that 1 centimeter distance on map represents 3 multiplied with 10 to the power of 7 centimeters in reality. So, I can explain it in this way, that if we have two objects at a distance of 1 centimeter on map, then the distance between these two objects in reality will be 3 into 10 to the power of 7 centimeter. This is what is indicated by the scale of the map. Now, two cities are 4 centimeter apart on the map. We have two cities and the distance between them is 4 centimeter on map. We have to calculate the actual distance between them. So this is the problem of direct proportion. So we wrote distance on the map in centimeter as the first variable. Let's say this is x, or we can just simply write that the distance of the map in centimeters. And the second variable that we have over here is the actual distance in centimeter. So when the distance on the map is 1 centimeter, the actual distance between them is 3 multiplied by 10 to the power 7 centimeters. Now we have been given the second case for which we have to calculate the actual distance, that is the distance between the two cities on map is 4 centimeter. So let us consider that the actual distance between them is x centimeters. Now in case of direct proportion, the variables are in a constant ratio. So let's take the ratio, that means x1 y1, this will be equal to x2 y2 because the variables, the ratio of the variable is a constant. So we'll have 1 by 3 multiplied by 10 to the power of 7 equals 4 by x, where x is the actual distance between the two cities. From here we can calculate the value of x, that is x is equal to 3 multiplied with 4 multiplied with 10 to the power of 7, and this will be in centimeters, which equals to 12 multiplied with 10 to the power of 7 centimeters. Now just because it is becoming a very big quantity, let's convert it to a bigger quantity. So that means we are converting the centimeter into a bigger unit, that is kilometer. So what we will do is we will write 12 multiplied with 10 square multiplied with 10 to the power 5, because this 10 to the power 7 can be broken up and written as 10 square and 10 to the power of 5 centimeters. Now we know that 10 to the power of 5 centimeter is equal to 1 kilometer. So from here we can write that 12 multiplied by 10 square kilometer. Now 12 multiplied with 10 square means 12 multiplied with 100, which gives us the actual answer as 1200 kilometer. So we can say that if the distance between the two cities on the map is 4 centimeter, that means the actual distance between them will be 1200 kilometers. So this was the end of today's session. Thank you so much for connecting me on Study Room. Hope to meet you in the next lecture where I'll be discussing you the opposite of direct proportion, that is inverse proportion.